two things. The two conditions. If it rains, and then what else? He has a game. And so those things, notice this is what I mean by it's conditional. They change based on if it rains or not. Okay, so if it rains tomorrow, there is a 40% chance Charlie will have his baseball game. And if it doesn't rain, there's a 90% chance. And so this isn't like the Skittles problem yesterday, where there were the Skittles in the bag. I mean, that's a set probability. This is a completely different probability based on what happens first. So what I'm going to do is I'm going to map it out, and I'm going to write my event A first. And my event A is either it will rain, I'll just kind of put it in a circle here, or there will be no rain. Okay. So what's the probability that it's going to rain tomorrow? 20%. So I'm going to put that 0.2 just right above here, kind of in there. And that implies then, what's the probability that it's not going to rain? 0.8. Okay. Then, if it rains, we have to take two scenarios from that. If it rains, it's possible there will be a game, and it's possible there will be no game. Okay, and so what I'm going to do then is write the probabilities of this conditional probability on the little line that goes towards it. Okay, so if it rains, in the problem it states what's the probability that Charlie will have his game. Yep, so what would that imply about the chance that he doesn't have a game? Yeah. But when you're doing, so I'm breaking it up based on that, but when I'm doing the complete probabilities, we have to multiply them together, and that's where this formula comes from. So this is 0.2 times 0.4. The probability of rain in a game is 0.2 times 0.4, which is 0.08. The probability of rain and no game is 0.2 times 0.6, which is what? 0.12. What is 0.08 plus 0.12? 0.2. Notice it adds up to that complete probability. I hope that makes sense to you, because those are the only two things that could happen. All right, let's go to the second scenario then. So if there is no rain, there is still those two possibilities of a game and no game. So it says here, if it doesn't rain, there is a 90% chance he will have his baseball game. So I'm going to put a 0.9 here, which implies what's the percent chance that he would not have a game? 0.1. But for the two conditions, no rain and a game, I'd take 0.8 times 0.9, which is 0.72, and 0.8 times 0.1, which is 0.08. Once again, 0.72 plus 0.08 adds up to that 0.8. And if you would add all four up, what should they add up to be? 1. Okay. So let's then use this to answer the question. Now, if going through you're just asked one question, do you have to do the entire tree diagram? No, but I just wanted you to see how that was set up. That's why the probability of A and B happening is you take the probability of the event A times the probability of B given A. That's what I was doing here. Okay. Tomorrow there's a 20% chance of rain, so we're in this scenario. What's the probability that Charlie plays his game? That's this one right here. So the probability that he plays his game is 0.2 times 0.4, which is 0.08. Okay. So that's conditional probability. And then the thing that we're going to actually spend the most time on, and we're going to spend some time on it today and then tomorrow, because it's kind of important, is binomial probability. And so I want to spend some time talking about what that is for our last example.